Okay, now we're going to be talking about how mountains can change, how rocks can change, how weathering changes everything from, let's say, this mountain. Now this mountain can shrink over time to something much, much smaller. Okay, now if we back it up, this mountain that we see here this is a lot like the Rocky Mountains that we see today. If you go to the Rocky Mountains, you see these sharp, angular mountains that are very, very high, very, very angular, very, very sharp, very tall still. But if we look at some older mountains, this would be a slightly older mountain. So this mountain's been here for millions of years, and we see that there's lots of sediment in the bottom. We see that the highest rocks have all worn down. There's not so many rocks jutting way up into the sky. There are still some, but not so many. Even older mountains look more like this. Now this is like the Appalachian Mountains in the East Coast. The Appalachian Mountains used to be much bigger than the Rocky Mountains, but the Rocky Mountains are so much younger. They still have their pointy tops, and they're mostly made out of rock still, whereas the Appalachian Mountains have had time. A lot of sand, a lot of soil is formed. A lot of the Appalachian Mountains are still, or are now covered with trees. And so as we let this finish, eventually a mountain will wear down until it's just a couple of bases sticking out the bottom, a couple of footings. Just barely let you know there's a mountain there. There was a mountain there. So these notes will cover how this happens. Okay. How something like this can form, where there used to be a sedimentary rock. Okay. Now in our rock cycle, as we are moving from any type of rock and going through weathering and erosion, we're going to be focusing on this area. This is the same areas here and the same area here. Okay. Now, sedimentary rocks form when fragments of other rocks get cemented together by dissolved minerals. But where do these rock fragments come from? The answer to this can be found in the rock cycle. We know from re-examining the rock cycle that any rock can become a sedimentary rock through two processes, weathering and erosion. These words should be familiar with you, but we will look at them in a much more in-depth way. Now this example here, what we have is a very large piece of coastline that has fallen into the ground, fallen into the sea, excuse me. Over here, what we see is what used to be a much larger rock. Now we have plants, everything else going in. So, in your notes, what we are talking about is weathering. And weathering is the breaking apart of the rocks on the earth. Now, there are many different processes that cause weathering, but they can be broken up into two main types. First is mechanical weathering. Second is chemical weathering. So everything we're going to talk about after this is either going to be mechanical weathering or chemical weathering. There are many processes, but they all can be broken into two main types, mechanical weathering and chemical weathering. So first, we're going to talk about mechanical weathering. Now, mechanical weathering, also known as physical weathering, occurs when a rock breaks apart or splits into smaller pieces due to exposure to the atmosphere. The important distinction here lies that it is a physical change has occurred. In other words, small pieces are exactly the same as the original rock, only smaller. This process can happen in several ways, so there are several types of mechanical weathering. Mechanical weathering is just mostly physical changes. Now the first type of mechanical weathering is ice wedging. What we have here is a nice little picture of ice wedging. Water is a very unique substance in the fact that it expands when it freezes. Almost all other liquids contract when frozen. Contract means get smaller. But when the water freezes, it becomes 10% bigger or takes 10% more space. This is unique to water. As water expands, it puts great pressure on the walls of anything containing it, including any rocks that happen to be surrounding it. When the water falls into the cracks of the rocks and freezes, the force of the pressure exerted on the rocks surrounding it is enough to wedge the walls of the crack further apart, thus expanding and deepening the crack. Okay. In short, ice wedging, water fills the cracks during the day. That night it freezes. The ice expands to make the crack wider, and this process repeats again and again. So, we're seeing water goes into a crack. This is during the daytime. Just a little bit of water gets in here. Maybe it was raining. Maybe this is dew. Maybe something else gets in here. But then that water freezes, grows the crack bigger, and then the next time, even more water gets in. The next day, more water freezes, makes the crack even larger. As this repeats, this is a very powerful way of breaking up. This is how our roads get so potholed and so bumpy and so broken up. Mostly because of ice wedging, and mostly because we have so many cycles of freezing and thawing and freezing and thawing throughout the winter. Okay, this will break apart rocks that are bigger than your house. It's very powerful. Up next we have plants and animals. So, plant and animal action. Some plants, like mosses and lichens, are capable of growing without soil on bare rock. When they do this, their roots penetrate pores and crevices and cause rocks to split apart as the roots force their way down in the rocks. So, tree roots are the most common example of this. Tree roots can grow into cracks and expand. Okay. This forces the rock apart. Okay. What we have here is a little tree growing right in the center of a rock. Here's another tree. As this tree gets larger, so will this crack. Okay. So, on to chemical weathering. Chemical weathering is different from mechanical weathering in that it is an actual chemical change in the properties of the rock that gets weathered. It mostly happens because of the actions of rainwater, CO2, and acids from decaying plants. Just like mechanical weathering, chemical weathering can occur via several different methods. First one, we'll spend the least amount of time on hydrolysis. What you need to know about hydrolysis is water breaks down rocks to form new compounds. So water will react with certain types of rocks and make clay and make something else. So just sometimes by getting wet, rocks will start breaking down and turning into new things. The second chemical weathering is oxidation. Oxidation, hopefully that's a word that sounds familiar. Oxygen in air reacts with iron to form rust. And what I have over here in the reading, oxidation is a type of chemical weathering resulting from a reaction between oxygen and other substance. Oxidation reactions are the reason that many things rust over time. Minerals and metals that contain iron react with oxygen to form a reddish color of rust. When both oxygen and water are present, the iron-containing minerals react to form a more brownish rust. Now, from the History Channel, they did a really interesting little thought experiment on what would happen if Earth were just devoid of humans, if all the humans just sort of disappeared. What would happen to all the things that we've built? And this is the section of that from what happened to our cars. So here's what would happen to our cars if all the humans disappeared.
Tires deflate within a few years, although the rubber and synthetics they're made of will remain intact for centuries. Paint deteriorates quickly, and once it flakes away, rust corrodes the car's body at a rate of 0.005 of an inch per year. 75 years after humans, most cars, even in the most forgiving of environments, will be reduced to skeletons. After a century, the family car is a barely recognizable heap of metal.
Kind of strange looking, but that's what oxidation does. We all have rusty cars at home. Okay. Last thing in the notes, last chemical change is acids. Now, acids react with many different types of minerals and rocks, causing them to dissolve. Acids may come in contact with rocks in a couple of different ways. One common way occurs when CO2 is dissolved in water, which creates carbonic acid, the acid in soda. But it can also enter the soil as decaying plants dissolve in rainwater. What I have is a video on the reaction between dolostone and a weak acid. Basically, the rock just starts bubbling just like baking soda and vinegar. Now, we're not going to watch this video, but if you want to see it, if you want to rewatch any of the videos I've shown you or reread some of the things that I went quickly through, you are free to go to these notes, click on it, go through it at your own speed. So please do that. Now, to finish your notes up, acids, rainwater and CO2, carbon dioxide, form a very weak acid. All right. Acid dissolves rock slowly over time, and this forms caves. If you ever wonder how a cave got underground, this is what happens. Rainwater slowly dissolves that rock away, mostly limestone. And that limestone just carries away with the water because it's a slight acid. Okay. The last example, this rock here, you've all seen rocks, at least some rocks, gravestones, old gravestones have these on them. These are called lichens. Lichens use acid to dissolve rock to get their nutrients. They don't need any soil to live on. What they need is a rock, and they make acid and dissolve the rock itself. So, in summary, weathering has two types, mechanical and chemical weathering. Mechanical weathering is really just physical changes happening to it. Chemical weathering are chemical changes. And weathering is the breaking down of rocks on Earth's surface. Make sure you review these. Make sure you understand all the different types of chemical weathering, all the different types of mechanical weathering that I want you to know.